Thank you for joining today's webinar using panel design tools in BD Research Cloud. What makes a good flow cytometry panel? A successful panel allows for clear identification of the desired cell populations. So in this case, you can see that this is a good panel design because you can clearly identify and gate on the PD1 positive events for both the CD8 negative and positive populations. Bad panel design will lead to problems accurately gating and quantifying populations. In this example, if we use again CD8 and PD1, but using different fluorochromes, you can see that assigning PE to CD8 leads to spread and resolution loss, which in turn makes it more difficult to accurately gate on the PD1 positive events. Many factors can affect the quality of a panel, and following the principles of good panel design will help avoid errors. So these principles of good panel design consist of assigning low antigen density markers to bright fluorochromes, and vice versa, assigning high antigen density markers to dim fluorochromes. For co-expressed antigens, choosing fluorochromes that don't spill into each other's channel. If you must use fluors that spill into each other's channel, either because there are no other fluorochrome options for that marker, or if you're doing a particularly large panel, then it's important to assign them to antigens expressed on different cells. And lastly, a consideration for spectral panels is to avoid combination of fluorochromes that lead to unmixing dependent spread. So hopefully you've already heard of most of these guiding principles, but you may not have heard of this last one. So avoiding combinations that lead to unmixing dependent spread. This is difficult to anticipate, and there are currently not many tools that allow for this. However, BD came out recently with the BD Spectral Hotspot matrix, which is unique to BD Research Cloud. So I'll spend just a moment explaining what this is specifically, the unmixing dependent spread. So in this example, if we look at single stain samples, so either Spark NIR 685 or Alexa Fluor 647 that have been unmixed with themselves and autofluorescence only, so they each been applied an unmixing matrix of 2. You can see that these have good resolution. So the negative population is nice and tight, and there's nice separation between the negative and the positive. However, if you take those exact same samples and apply a different matrix to them, in this case, a 40 color matrix, you can see that the single stains are affected by this unmixing dependent spread, and this leads to widening of the negative population and a loss of resolution. So in this case, you can no longer accurately gate on those dim events. Unmixing dependent spread typically happens with similar fluors. So if we look at these, they do have a similarity score of 0.89. So you might think that using the similarity matrix alone can help you prevent this error. However, here is a different panel, and we're looking at the similarity matrix here. You can see that there are high values in the darker red based on the scale. And so simply looking at the similarity matrix and having these higher scores in many places, it's difficult to tell which one of these combinations in the context of the current panel will lead to unmixing dependent spread. Using the new tool that we're providing in BD Research Cloud, the hotspot matrix, this quickly tells you which exact combination of fluorochrome is leading to this unmixing dependent spread. So it takes the guesswork out of it. Additional considerations for panel design. Obviously, it's good to decide ahead of time which cytometer you'll be running your panel on. This will affect which fluorochromes can be run on your cytometer, depending on the lasers it contains. The laser power will affect the quality of the fluorochrome signal that's coming out of it, and the detectors and configuration will also dictate which fluorochromes are best for your specific panel. Marker selection. Which markers are needed to identify the population of interest? Which markers are critical versus which ones are nice to have? So these considerations for marker selection will also dictate your panel size. And a good question to ask yourself if you're trying to put in many markers is, do I really need to have one large panel? It might be very difficult to try and put them all in versus 2 smaller panels. The 2 smaller panels may lead to better resolution of individual markers, but then you might not be able to assess co-expression. So these are all questions that you need to ask yourself while designing a panel. The clone selection is another important question. Lastly, fluorochrome assignment will depend on the antigen expression patterns of your markers. You need to consider brightness of the fluorochromes and co-expression of the antigens on the same cell. So as you can see, there's no one size fits all for panel design. And that's why in BD Research Cloud, we provide these tools for you to help assess all these different factors that may affect the quality of your panel. So in BD Research Cloud, we have a 5-step workflow to help you create your panel. First step is selecting your cytometer. So that will dictate the lasers, laser power, detectors, all that. On the second step, you will be selecting your target. So your antigens, your markers that you want to include in your panel. But then also we'll define some populations and specifically look at co-expression to see how they may affect your fluorochrome selection, which is on step 3. On step 3, we'll assign fluorochromes to specific markers and see how well those fluorochromes work with the cytometer that you've chosen. And the last 2 steps, so the subsequent steps, select reagent, is where you select which clone is best for your needs based on your fluorochrome selection. And lastly, you create a shopping list of the final reagents. If you're not familiar with BDRC, so I'm going to jump into the demo now. What I've already done is I've created a BDRC account and a collaborative org. I've uploaded a cytometer and I've predefined a population of interest. What I was going to say is if you're not familiar with BDRC, to create a free account, all you have to do is go to bdresearchcloud.com and enter your FlowJo portal ID credentials if you have them. If you do not have them, not a problem, just press create account button and it'll create those credentials for you. You do not need to have a FlowJo license to have a BD Research Cloud account, so anyone can sign up here. And if you need help setting up your account or uploading a cytometer, there are lots and lots of resources available for you. Within BDRC, we have icons that you can press on that provide additional information. So these are the built-in tutorials or tech support, or we have external links that provide short videos on how to do steps within BDRC. This webinar and others that have been previously recorded are available here in FlowJo. And of course, you can always reach out to me directly if you want help setting up your lab or if you want to schedule a training. So hopefully I can figure out how to get out of here and jump into my demo. Let's see here, Zoom. Okay, so here we are. Let's try and make this a little bit bigger. So you can open BD Research Cloud on any browser. Just go to bdresearchcloud.com and enter your credentials here. Let me see if I'm able to access the chat now. No, I don't know how to access the chat. I apologize. Let's see. Okay, so by logging into BD Research Cloud, you arrive on the homepage. The homepage shows different tiles of the different sections. So there's a lot you can do within BD Research Cloud. Today, we're going to focus on panel creation, but just very briefly, you can not only view and create panels, but you can create FACS-DIVA experiments away from the cytometer. You can create customized workflows to keep track of who did what in the lab with timestamps and tasks assignments. You can upload data directly to BDRC with connectivity to FlowJo to analyze your data from anywhere. Here is where you would upload your cytometer. I'll come back here in just a second. You can also upload the reagents that are in your lab and keep track of titrations, and you can use those during your panel design. Next tile over is where you would go to define populations that will also come in handy during panel design. And then the last 2 tabs are groups and projects and users. So this is to set user permissions to dictate who has access to your data. But if I go back first to the cytometer section, so by clicking on this tab, I will now see which cytometers I have uploaded to this particular organization of BDRC. So these are the cytometers that I have uploaded that are available to me. Of course, we have in-system cytometers. We have the BD line of cytometers and also a few others that have common or default configuration. So you can always use one of these if you're just playing around with BDRC for the first time. But if you do want to create your panel, I would recommend uploading the exact configuration of the cytometer you're planning to use. To upload a cytometer, you would just go to this add button over here. If your cytometer runs FACSDIVA, we recommend you upload a FACSDIVA export configuration file. If your core lab has access to BDRC, you can look up which, so for example, the Fred Hutch, I can click on it. You can search for your core lab up top here and then see what cytometers they have posted, and you can click on them and link to them to use that configuration to design your panel. Lastly, you can upload your own, either by uploading lasers and detectors one at a time, or you can punch in a base cytometer, so one of the BD default cytometers, and make a few tweaks if needed to add your cytometer. So that's, I won't spend too much time here, but I just want to show you that's how you would go about uploading a cytometer. So if I head back to the home panel, so I can press on the individual tiles to access the different sections, or you can also access those same sections with the tabs above. So before we jump into panels, one last pit stop is populations. BDRC comes preloaded with literature-defined populations that can come in handy during panel design. So if I click on this first one as an example, B cells in this case are defined, human B cells are described as being CD3 negative or CD19 positive. So these are just basic definitions of common cell populations. It comes with a link to the citation. Within this population section, you can add custom populations. So in this case, I created this EJ Treg. EJ are my initials, this Treg definition, where I've assigned CD3 as a medium antigen density marker for this population of interest. CD4, I've assigned it as a high antigen density marker. CD8 is negative, CD127 low, CD25 high, and FOXP3 low. So later I'll be coming back to this population to show how to use it within BD, within panel creation. So coming back to home, this time let's go ahead and click on the panel sections. When in the panel section, you land on the custom panels tab. This shows all the previous panels that either I have, that yourself has created or any of your lab mates have created. The one tab over are published panels. So BDRC comes preloaded with many OMIPs and other published panels. For example, if I click on this 50 color OMIP 102, I will see the details of this panel. Right, so which antigen was used, which fluorochrome, which clone, the catalog number. There's a link to the citation. If I tab over to the next tab, it shows which cytometer the panel was developed for. And also the visualization tab will show the spectral signatures of the fluorochromes used in that panel. You can change the view to either the spectral signature graph view or the conventional view. And if I scroll down here, I have access to the similarity matrix of the fluorochromes used for this panel or the BD hotspot matrix. So this one highlights the areas where there might be unmixing dependent spread. So coming back to the panel section, if I click on the All tab, I can search through all of these panels, my own and published panels, to see if there's any that suit my needs. So you can put multiple antigens here in the filter, and it will restrict the list to only show panels that contain the markers of interest. So CD45, for example. So now it will only show panels that contain both CD3 and CD45. So you can put a long list of antigens here and see if there's any published panels or previous panels used by other lab members that might suit your needs. But let's go ahead and create our brand new panel using BDRC. So to do so, we would hit this button, blue button in the upper right corner, right below your name, create panel. I'm going to name this panel EJ webinar, for example, and then assign it to a project, and I will be creating a new panel from scratch. So let's go ahead and click start. So first step in panel creation is selecting a cytometer. By default, it selects the last cytometer I used. But if this is the first time you're in this page, this is what it will look like. By clicking in the select a cytometer box, it brings up the cytometers that you have uploaded in that My Cytometer section. If you want to see the additional cytometers that have been uploaded into BDRC, so the BD default cytometers, I can add those into the drop-down list, or I can keep those out and only have the ones that are available to me. So I'm going to go ahead and select the A5SE for today's demonstration. If I want to double check the configuration of the cytometer to make sure, yes, this is the one that I intend to build the panel for, then I can go ahead and press complete step. So now we're on to step 2, adding the markers that are of interest for my panel. So first step, select target species. I will be building a human panel today. And if I want to add my first marker, I'm going to add it here. So CD3, add. And let's add a few more. Let's say CD4, add, and CD8, add. So by adding the markers, it adds them to the table below. What you'll notice is on the right-hand side here, there's a population section, and that's what I'll be talking about with you. This is where you want to define your populations and assign antigen density, and that will really help you out for the next step on step 3 when you're assigning your fluorochromes. So I could just say, oh, CD3 on T cells is, mid, CD4 is high on CD4 T cells, CD8 is high. So I could assign antigen density that way. However, it doesn't represent when I gate, I'll be gating on specific populations of interest. I won't be gating on all T cells at once. I'll be looking at just CD4 T cells and just CD8 T cells. So in that case, I won't be getting co-expression of CD4 and CD8. So in that case, I might want to generate more than one population of interest. So by pressing this little plus button, I can add additional populations. So let's go ahead and rename this one CD8 positive T cells. Submit. I'm going to rename this one instead of leaving it the default population. I'm going to rename it CD4 positive T cells. And so now I can assign population-specific antigen density that's relevant to my downstream gating strategy. So in this case, CD4 and CD8, they both have the same antigen density value. So I'll assign CD3 mid to both of them. For CD4 marker is high on CD4 T cells, but it is negative for CD8 T cells. And CD8 is now negative for CD4 T cells and positive or high for CD8 T cells. So I could continue with additional markers, let's say CD14, and add it slowly here, or I could use one of those predefined populations. In this case, monocytes. Monocytes have been predefined by BDRC as being positive for CD14 and negative for CD3 and CD19. So if I select this population and click add, what happens is that it adds this new monocyte population to the population table, and it also adds any markers that weren't already there. It includes antigen density information based on its definition. So it added CD3 negative for the monocytes and CD14 positive, CD19 negative for those markers that were a part of the definition of monocytes. For any additional markers, it left it as unknown, so question mark. So now it's up to me to fill in the blanks of these different populations to the best of my ability. We definitely recommend you do some literature searches, that you look at other OMIPs that might use the same markers that you're planning to use to best assess the antigen density on these different populations. The better you fill this table out, the easier it will be to make good fluorochrome choices in the next step. That said, this step is completely optional. You can assign no population and not fill this out. So don't let this be a hindrance thinking you need to know everything. You just fill out to the best of your ability. So if I just continue here, CD4 on monocytes, let's leave it as unknown or variable. CD8 is negative for monocytes. CD14 for T cells will be negative. CD19 for T cells is negative. Same for CD8 and for CD19. And I can add as many populations as I want here. You can expand this section to add additional populations if you choose to. Let's say I want to add one more marker, CD20, which is a B cell marker. I'm not particularly interested in B cells, but I want to use these B cell markers together, assigned to the same fluorochrome to gate out any B cells that I'm not interested in. So if ever you want to put these in a dump channel, then you can do so by checking this exclusion box. And now it will assign a negative antigen density to all these populations because I do not care about these markers and they're not a part of these definitions. All right, so let's see. What you may have noticed is that we have these boxes at the top of every step. So the step has been started by me. I can always choose to assign it to another member of this BDRC org. So members of your orgs are usually your lab mates. So if ever you're working with another person in your lab to design this panel together, you can send it back to each other by assigning the steps. So let's say I could assign it to this person. I would just press assign. They would get an email saying, hey, there's something for you to look at in BDRC. Let me know what you think. But this is also optional. You can choose to just proceed yourself. What else? I talked about the markers, talked about the populations. Oh, you can include a viability die. Options during panel creation. If you look for an antigen and it's not there, for example, so I might have created some tetramers in the past. So tetramers, these show up. If these are not the tetramers of interest, I can always add a custom reagent. So I would click on here, this little window would come in, I would create the reagent. I'm interested in what fluorochromes it comes into, and I would press add, and then it would be added to this list so I can create the panel with it. Same with populations. You can scroll to the bottom here and add a custom population, and it will get added here as opposed to creating it directly on the table. So you have several options there as well. If there are specific clones that you know you want to create your panel with and you don't want any other clones, you can choose to do so. So for example here, I'm just going to use FOXP3, add it here because I'm going to do FOXP3. Oh, you know what? Here, let's go ahead and delete it. I had created my EJ-FOXP3. That's what I meant to do. So let's go ahead and add my EJ-Treg population. So now it's showing up here. That was the population I highlighted when I was in the population section. So it automatically brought in the high or low antigen density information, and it put question marks where it wasn't a part of the definition. So I'm just going to fill in the blanks here. For the EJ-Treg, I'm not going to look specifically at the CD4. I'm going to focus on the EJ-Treg for today's purposes. So for FOXP3 here, if I wanted to restrict and only use one of these clones because it's my favorite one and I don't like how the other ones are working, you can make that selection at this point, and it will only show you what fluorochromes are available for that specific clone. The last option to highlight here is you can restrict which reagent type you move forward with. So right now we're not going to restrict anything. We're going to use all reagents. All right, so now that we've defined our populations of interest using this table and assigned antigen density, oh, FOXP3 here, I'll do negative for this, negative monocytes are all negative for this. Okay. So I'm going to move on to the next step. So this is where you will assign your fluorochromes and keep in mind co-expression information, antigen density, and all that good stuff. So we're on step 3. The middle section shows the list of markers that you added in the previous step. So if I click here on CD3, the list of fluorochrome updates and shows me what CD3 is available in. I can click on the different fluorochromes to view their profile. So here it's because I selected a spectral instrument, the default view is a spectral signature graph, but you can also change the view to the combined, where you can click laser line by laser line to see the specific detectors. You can switch it to stacked view to see all laser lines at once. So the filled curve shows the emission on the primary laser, and then the dashed curves shows you the spillover, the cross laser spillover that the fluorochromes might have. So back to the spectral signature view. If I look below the spectrum viewer, you see the population table that you created on the previous step, and you'll also have these two other tabs, the similarity matrix and the hotspot matrix, that will become available once I've assigned fluorochromes to markers. So where to start? You have a list of markers. Typically, you want to start with your most restrictive or important markers first to assign them the best or only options available for those markers. So this list of markers, I can sort them by fluorochrome availability. And I can toggle if it's sorted high to low or low to high. So what this is telling me is that viability dye comes in the fewest colors and CD3 comes in the most available colors. I tend to assign viability dye last because it has quite a bit of flexibility. So I'll just select the next one down the list. So FOXP3 comes in the fewest amount of colors. And if I look over at the table here, it's negative for my populations, for many of my populations, and my one population of interest here shows me that it has a dim antigen density. So I want to assign it a bright fluorochrome. So here there's the brightness scale, 1 to 5. And I can sort these fluorochromes either by the brightness of the fluorochrome, again, low to high, high to low. I can sort it by resolution. I can sort them by laser line, alphabetically, or I can look up by filtering by the search box. So FOXP3 is a low antigen density marker. I want to assign it a bright fluorochrome. So if I do select bright, high to low, I can then start seeing which one of these is best suited for my cytometer. This little check mark here indicates that I do have this FOXP3 PE already in my inventory. I've filled out the BDRC inventory with the reagents that are available in my lab. I know that I've used this in the past. I like it. So I will go ahead and pair FOXP3 PE with this fluorochrome. By clicking the paired button, it moves the antigen out of this list and puts it up top here. And now the fluorochrome profile will become permanent on the spectrum viewer. So as I add other fluorochromes, I get to see the interaction with my previous pairings. So if I move down the list based on fluorochrome availability, CD127 is next. And if I look at my table at CD127, I can see that it too has a low antigen density. So I'll want to assign a bright fluorochrome. Now that I've paired PE already, CD127 comes available in PE, but it's hashed because I've already paired it. If I don't want to see anything that I've already paired, I can use a toggle up here to say hide anything that's already been paired. And what you'll notice is that other fluorochromes may have red box warnings around them as well, such as this one. So if I hover over it, I can read what that warning is. In this case, RY586 has a similarity score with PE that is above 0.9. I can now click over into the similarity matrix and see what that value is by clicking on 586. And in fact, yes, this one has a high similarity. I may or may not want to use these two together in the same panel. If I don't want to see any fluorochromes that have these warnings, I can say hide any conflicting fluors, and now it removes it from the list. And what I'm left with is fluorochromes that have lower similarity values. So I can continue and click on the different fluorochromes and determine which one I want to assign to my marker over here. Ideally, you're trying to spread out your fluorochromes across laser lines and also keeping in mind your antigen density. If I click on the hotspot matrix here, I can see those values populating. If you want to better understand how to read the hotspot matrix, here are the two icons that I mentioned earlier in the slide. So we have the tutorial that I can click on it. The content of the tutorial changes based on what page you're on in BDRC. So here we have several links to learn more about panel design. Click here. This will bring me to a BD page where it goes through those concepts of good panel design. If they're not top of mind, you can click on it and reread them to know how best to assign your fluorochromes. But if you keep scrolling, so there's a lot of information. It tells you how we've calculated the brightness and the resolution for these fluorochromes. But at the very bottom here, it talks about the hotspot matrix. So it talks about the hotspot matrix, how it works, and then here, how to read a hotspot matrix. First, look at the diagonal entries. Each diagonal entry in the hotspot matrix corresponds to a single fluorochrome, and its value indicates the severity of unmixing dependent spread that fluorochrome will experience in the context of the current panel. A diagonal hotspot entry of 1, which is what we are seeing here, indicates no unmixing dependent spread is expected. And a diagonal value greater than 1 represents the factor by which unmixing dependent spread would amplify the noise in the unmixed data. A fluorochrome with a diagonal hotspot entry exceeding 3 will probably have noticeable unmixing dependent spread. So here we're looking at so I'll just press here. So to read the hotspot matrix, we're looking at the diagonal and we want values of 3 or lower ideally. Of course, this will depend on your panel size. The more fluorochromes you try to put in there, the more you'll have the opportunity to maybe have this creep up in value. But that said, if I want to assign a fluorochrome to this marker, I look at the antigen density of CD 127, which is low. I want to assign it something that's nice and bright. So let's go ahead and assign it, I guess it doesn't really matter, something that's out of the way. Sure. So then moving down the line of fluorochrome availability, so everyone has their own way of building a panel, right? My way may be different than your way, but in the end, what we're all trying to do is look at antigen density and assign it the correct brightness of fluorochrome. I like to fill out my panel that way and then come back and reassess co-expression. Your mind might work a little bit different. Maybe you want to start with co-expression first and then play around with brightness in a secondary factor. You know, that's why we have tools that you can play around with. You can add things, remove things. So let's say I didn't like this pairing of CD127 to Nova Fluor. I can unpair it and then reselect something else. Let's go ahead and just select BV421. So CD14 here, I didn't put any antigen density. It was a default value of positive. So maybe I want to assign it an intermediate value of brightness. I personally prefer to look at laser line to try and space these out and then find something bright within that. So maybe in the UV line, starting up top here, I look for something intermediate. Maybe you can look at the profile, see how it works best for your cytometer, and just click on them and make a decision. I don't want too much interference, so let's go ahead and there. So CD25 now is nice and bright over here, so I'll want something dim. So I'll want a dim fluorochrome for this marker. So looking at the dim fluorochromes, this one is nice and dim. It's out of the way. Let's go ahead and do that. CD8 now is bright, so I want something dim. And what I'm doing is I'm looking to see where are my spaces that I haven't already assigned fluorochromes. So maybe more toward and then here, these are sorted by laser line. So I'm scrolling down violet, blue, yellow, green. Let's start over here. That's not bad. Let's go ahead, real yellow. Scroll back up, CD4. Maybe something in the red. We don't have anything there yet. RY, nice out of the way. So what's great about the latest line of fluorochromes of real yellows and real blues is that they have a very narrow excitation peak so that they don't have these multi-peaks across multiple laser lines. So those are really good choices, especially for spectral or high parameter fluorochromes. Or sorry, high parameter panels. Okay, last marker here, CD3 is medium antigen density. Let's go ahead and give it a medium fluorochrome that's out of the way. Just for kicks, let's maybe something a little bit brighter. So CD3 will be expressed on all the T cells. So I want to make sure it doesn't interfere with any CD4 or CD8. So let's go ahead and put it there for now. And the last one, or last two, these have much more flexibility, the exclusion channel and the viability dye, because you are gating out cells. So they have a bit more leeway. For viability dye, I tend to like the far red. Let's go ahead and do that. And then CD20 and 19, are there any gaps that I can fit something in? Maybe yellow, green, something in here, perhaps. APC is not too bad. So I won't spend too much time making a choice here, but I'll show you how to evaluate. So once I've assigned all the fluorochromes, now I have a better image of what a potential panel might look like. If I want to remove certain fluorochromes from the spectrum viewer, I just hide them from view or put them back from view. But because we spent all this time optimizing the populations table, what I can do is click on the eye icon here for this first population. So for CD8 T cells, by pressing the eye icon, what it does is that it removes from view any of the markers that have been marked as negative. So in this case, CD8 T cells will only truly have these two fluorochromes assigned to this population. So I can, in isolation, look at the fluorochrome profile of this population and see if there will be any co-expression issues. And in this case, no, this looks great. So if I move on to my next population, monocytes, now I can evaluate with these two fluorochromes that have been assigned to them. So this was the CD14 and CD4, because I left it as, who knows, maybe monocytes do express low-level CD4. So I can assess, do I anticipate any issues between these two fluorochromes? So in the spectral, I can I can look at it and assess if this is acceptable. If you were assessing a conventional view, this is how it would look. So you see the main fluorochrome profile of BV650 on the violet. You can see that this fluorochrome will cause this amount of spillover in the UV. Luckily, for this given population, we're not detecting anything on the UV, so we know that this won't be an issue. This won't be an issue. And if we scroll down, CD4 is assigned to this fluorochrome, and we'll have very minor, I don't know if you can even see that. There's like a tiny little hump here of this fluorochrome that gets slightly excited by the violet. So I'm not concerned at all by these two fluorochromes being on the same cell type, so I am happy with that. Then I can move on to my other population, EJ-Treg. So this one had more fluorochromes assigned to them compared to the other ones, and I can individually assess to see if these are problematic. Do they spill over into each other significantly? Because if they do spill into each other, then I know this will possibly lead to spread and loss of resolution. If the labels are bothering you, you can always hide them. So by hiding them, you can have a better view. And you can go through individually and see if on your specific population of interest, the choice of fluorochromes are problematic or acceptable. Last glance, you can look at the similarity matrix. These are all low values. Of course, as you get into higher parameter panels, you might be forced to have high similarity fluorochromes, and that's okay, as long as they're potentially on different cell types. So that's what we just assessed here. Looking at individual cell populations. And the hotspot matrix, you want to make sure that in the context of this panel, there aren't any pairs of fluorochromes that are bringing this diagonal value to a number greater than 3. For any given panel, you can glance at the complexity score. So if you're building a 10-color panel, the lower the complexity score for any given 10 colors will be preferable over a higher value. And again, the complexity score, there's more details in the tutorial, and we talk about the values and how to use that during panel creation. So if I'm happy with this, and if I'm not happy, I can always unpair it and choose different fluorochromes and just play around until I get to a spot where I'm happy after assessing the populations individually one at a time. I can always save it and assign it to somebody. I can send it to my boss, send it to a coworker. They'll get a notification, say, hey, what do you think of this panel? And they can come back and look at it and say, I don't know. What do you think about this? All right, moving on to the next step, assuming all my coworkers are happy with these choices. Then we get into clone selection. So for my given antigen, in this case, CD3, and the fluorochrome I've selected in the previous step, clicking on the drop down here shows me what clones it's available in. So in this case, it comes either SK7, so I can click on SK7 image to show, okay, do I like this staining or not? Or if I want to learn more about it, I can click on the link. It'll bring me to the BD website page and tell me more about this reagent, format details, citations. I can look to see if I like their staining and so on. So there's lots of options here to help you decide which clone is best. So you just have to scroll through and decide which one is best for your needs. We also list the list price, so just the default price. It won't be, reflect your pricing per se, but it'll give you relative pricing information. And so you just go through the list. If I already have it, I still get that little check mark saying you have this in the lab. And it gives you an estimated total cost for your panel given the selections here. Again, that you could have assigned it to someone else in your lab. And then the last step is just finalizing your shopping list. So because if you are using the inventory, you can just remove the inventory items. I know that I have this in the lab, I can remove it. So by clicking this button, it moved the FOXP3 away from my shopping list, and left everything else that I don't have. If I am not using the inventory feature, not a problem. I can just go through the fridge or what other inventory method I use and remove things that I know I already have. And I'm just keeping the top items to place in order. So now I'm ready to finalize the workflow. And this is the last step. I can either add the reagents directly to the BD cart if you are able to order that way. If not, you can always email your shopping list, PDF or CSV to your admin to place the order. You can download the total panel, PDF, CSV, or just the shopping list. Or you can request a quote by pressing this button. It will send a list of all these reagents to your local BD rep who will get back to you with optimal pricing. So if I'm done, I want to see what the panel looks like. So if I click on View Panel, it brings me back to that panel section and it opens up panel details. So the panel details shows me a high-level view of the fluorochrome choices that I've made and the different antigens. If I click on cytometer, shows me which cytometer was used to optimize this panel. I can click on visualization to view, to get back to the spectral view. I can click conventional, reassess. So after staining, if you do see you're running into problems, you can come back and say, oh yeah, I didn't really anticipate this. That was not a great decision. Let's use this as a base and make a few simple swaps. You get reminded of the complexity score. So here in the details page, you can use this panel as base. So it would restart the same 5-step process, but it would pre-fill it with your previous choices. So you cannot modify an existing panel. This is a set panel, but you can always use it as a base, and you can always delete this panel if you no longer want it. So you can use this panel as a base and restart with these pre-filled options. And so back to visualizations, you can play around with the spectrum viewer and then get reminded of the similarity matrix and the hotspot matrix. So as you make more and more of these panels, you get to make better correlations of how certain values get reflected on your specific system. There is a staining sheet option for finalized panels. If you have this reagent in your inventory, and if you've already added titration information, whenever you create a panel with this marker, this gets pulled in automatically. So it shows me what lot is already in my fridge and what titration value I've assigned it to. So if these were all added in my inventory, this would all come pre-filled and I wouldn't have to go hunting for titration information in various places. If I don't have it in my inventory, not a problem. I can create a staining sheet. I'm gonna just make random numbers here, 200, let's say 1 in 300, 1 in 400, just to demonstrate this ability to create a panel. Once you have titration information, you can press save. You can write the lot numbers that are written on your vials. And let's go ahead and create staining steps. So by creating a staining sheet, I will just simply assign which markers will be used in different staining steps in the lab. So let's go ahead and click add. So here is the panel that I've created on the left-hand side, and here is my first staining step. So let's say staining step 1 is just viability. So I want to bring in, this is a drag and drop functionality. I can drag and drop the viability dye into this table. I can say what the staining buffer is. So for viability dye, I don't like using wash buffer. I want to avoid any protein as to not interfere with any of the amine dyes. So viability dye, PBS, all I have to say is what my total staining volume is and how many samples I plan to stain with. So let's say if I leave the default 100 and I plan to stain 5 samples, the math here gets automatically updated, and I can then know exactly what the volumes are for the master mix. So this will create stain step 1. And I want to add a second stain step. When I press it again, now it shows me which ones have already been included in previous staining step. This is staining step 2. I'm going to go ahead and say this is my surface. So I want CD3, CD4, CD8, 14, 19, 20, not FOXP3. This is intranuclear. This is surface as well. CD25 is surface. If I'm using any brilliant UVs or any brilliant fluorochromes, I will want to include a brilliant stain buffer. So I can drag any one of these with the recommended staining volume for that sample. Again, I can change the staining volume to whatever I want and number of samples 5, and it will update the math for me based on the titration information I have provided. So let's go ahead and create the second stain step. So I have a viability staining step, surface staining step, and I'm going to add one more, which is going to be the intranuclear. And this is going to be the transcription factor buffer that I'm using. Transcription factor buffer instead of PBS or wash buffer. And I'm just going to drag in FOXP3. This one has PE. And so again, I can update the number of samples and staining volume as needed. So if I have FMOs, I can always change these number of samples as well. So here are the different staining steps that I've created for this panel. I can choose to download a PDF or a CSV. So now it shows me here in a nice printable format, or for record keeping, you can paste this in your electronic notebook or in your paper notebook as a record of what you stained your samples with. So that is what I had planned to show today. Maybe very quickly, I can show you the resources that will help you on this, the step 2, where you're defining your different populations and assigning antigen density. There are different sources that can help you. Obviously, there's OMIPs. If you're working with human samples, the HCDM is a great resource. So they have characterized CD 1 to 300, I believe, in terms of antigen density for a bunch of human cell types. So this information is found on the CD maps. You can look at the publication to get more information. So CD maps dynamic profiling of CD 1 to 100, and they've added since more stuff there. For BD Biosciences, we have a human CD marker chart, and we also have a mouse one. The way it works is you zoom in. So here it shows you the CD number over here, and then it shows you the different cell types. So T cell, B cell, dendritic cells, all that jazz, and it shows you if that marker is present or not for that cell population. So this could also help you in defining the positivity and negativity of your populations table in step 2. The interactive human cell map is another BD tool that is quite interesting. In this case, step 1 is to select your favorite cell type. Step 2, discover key cell markers. And step 3, explore pre-optimized panels that BD has put together. So we have all these panels in BDRC. Remember, in this BD define, we have all those predefined panels, but you can also access them here. So let's say get started, select a cell type. So all of these are clickable. For me, I like T cells, I like conventional T cells. So I'll go ahead and click on that population. It will show me what cell surface markers are commonly used to define them. I can click on any one of these for more information, or I can expand to see more subsets. So it shows me that T cells come in CD4 or CD8. If I'm interested in CD8, I can click on that. I can expand it even more for additional cell subsets. In this case, I can click on effector memory CD8s. It shows me which additional cell surface markers are relevant for this population. And I can click on view panels that shows me a list of panels. All of these are in BDRC as well. If I click on this first one, it will show me what the panel consists of. But what I really like is that it comes and shows you the gating strategy that comes along with that panel. So even if you don't plan on using this exact panel, having the gating hierarchy and the examples of good staining examples of those different markers is very helpful when you're doing that literature search to fill out step 2. I'm trying to think if there are any other. Stop sharing. See if I can get to this chat list. Oh, there we go. From the top. Yes, everyone can hear. Perfect. Would AI help on this step? Marker density? Yeah, I have not personally tried it, but that's a very interesting thought. I would just be careful. I have attended some AI workshops where they're like, be careful, AI tends to make up data. So always ask for a reference or a source. If you're asking AI to come up with antigen density, ask it to provide where they got that information so you can double check and make sure it's good. Can you only add your reagents if you are a premium member on the cloud? So to make sure I understand the question. So this is for the inventory feature, I'm assuming. If it is, so the inventory feature, yes, is a premium feature. Oh, I'm not sharing. Let me share my screen again. Share here. Hopefully you guys can see. Back to BD Research Cloud. Okay, so in the upper corner in your name, you can create an organization. If you click on that button, you can see the different license types. So when you first log in, you are given an individual account. It comes with many features, but not all. You can also create an essentials free organization that comes with a few additional features and a bit more data as well. So these two are completely free, and you can create your panel, you can create DIVA experiments, you can create populations. So you can really do a lot with the essentials, but for the professional and premium, the additional paid for features are the instrument monitoring with a surety link. So if you have a BD instrument that is monitored by RSS remotely, you can view your QC reports directly in BDRC. So that only comes with the professional license. Reagent inventory management, I believe this is what you were asking about. Yes, that is a premium feature. And that also includes the antibody titer management that comes in and fills in your titration information. But if you don't have it, you can always just manually enter it for the staining sheet. So this is not a prerequisite to be able to create staining sheets. You can still create staining sheets without the premium account. Sharing files outside of the organization is a premium feature, and also sharing panels with users that are not a part of your organization is a premium feature. So the essentials one, which is completely free, you are allowed up to 10 users per organization, and you have 5 gigabytes per user. So that's a total of 50 gigabytes per for that organization for free. If you want more storage, then you will need to upgrade to professional or premium. All right, back to the chat questions. Hopefully that answered that. This looks helpful. Great. Can you only add reagents if you are a premium? What is the cost per year? Is there a discount if you already have FlowJo? Okay, so pricing I can't answer directly. Feel free to reach out to me. I don't dictate the pricing, but I can connect you with the right person. Let's see. Question, did you C4 darker from antigens, but CD3 is lower, but CD4. Okay, sorry. Nice. My question is, why did you assign brighter fluorochromes to CD4 and CD8, but darker fluorochromes to CD3? From antigen expression level, CD3 is lower, but CD4 are higher. So you are correct. I wasn't, I was trying to go fast. So if CD4 and CD8 are brighter, if CD4 and CD8 have higher antigen density, then yes, I would put a dimmer fluorochrome assigned to those markers, and vice versa. If CD3 has lower antigen density, then ideally you would put a brighter fluorochrome. That said, the difference between a brightness level of 2 or 3 is not a deal breaker in my opinion. Again, it all depends on which cytometer you're using and how it gets reflected once you've seen a stain sample. But yes, good question. You are correct. Okay, that's it for questions in the chat. And we are at time. So thank you very much for all of you who have attended. Let me just flash the resource page again to you. So this webinar is recorded and it will show up in the share, in the recorded webinars page. So here, FlowJo University, I can show you how to get there. So from FlowJo, just go to flowjo.com. If you go to the Learn, these two tabs, Webinars and FlowJo University. Webinars are where you might have gone to register for this webinar. There's other FlowJo related webinars coming up that you can sign up for. If you keep scrolling down, this is where you get the recorded webinars. So you can click on here and then you'll find mine soon and other past ones, and any other very helpful and insightful webinars can be found here. Alternatively, instead of going to webinars, if you go to FlowJo University, that's how you access the tutorials. So you can have, if you go to BD Research Cloud over here, you can click on them. These are short videos on a quick overview video, how to create an account, how to share and invite users, how to define your cytometer, how to apply a license. So these are just a few minutes long and can help you out if you have any questions. But like I said, if you're in BD Research Cloud, you can also click on the tutorials on different pages and they provide additional information in case you have any questions. I'm going to stop here. Thanks again for everyone who has joined. And I hope you have a great day and feel free to reach out anytime to me or any other BD associate. Thank you.